Hey guys, how are you guys doing? I'm Harold Serrano and I developed the Untold engine. And to all of you watching, thank you for joining my channel today. I was supposed to do the a stream on Thursday. However, I was a bit sick. Basically, my eye got irritated. I do not know why. I think it's because of allergies. But I couldn't really see, so I decided not to do a Twitch on that day. Um, so I decided since it's Saturday and my soccer game got canceled, I thought, well, why not do a game dev today? So here I am. Um, so what have I been doing the whole week? Basically, I don't know if you noticed, but I got a new logo for my blog. Let me show it to you. I actually like it quite a lot. I hired this guy that I found on Twitter. He's a graphics designer, and he did this logo for me, um, which I like. I got a new logo, Hero Serrano. He didn't charge me that much, which that was good. Aside from that, I've been actually working on implementing new features for the engine. Actually, last night I was up till like 2 a.m. reading some articles on how to do a terrain system for the engine. That's what I want to focus on next. Um, One thing I wanted to talk to you about is that the other day I saw a tweet about, you know, most of us, I think every developer out there uses Git, right? And some of us use the Git command line, and others we use the Git, the GUI, right? And there was a discussion whether which one is better to use. I didn't comment on that tweet, but I want to give my opinion to you guys about, what should you use, the command line or the GUI. In my opinion, it boils down to whatever tool makes you more effective. Um, if you are more effective using the command line, then go for it. If it's the GUI, then do so. I actually use both. I use the GUI because honestly, it's easier to work with in when it comes to uh, checking out the difference that you have done between the files. You can easily just check which lines you modified and which lines you deleted it. That's kind of hard to do on the command line. Yes, you can do it, but I just do not like it. Um, However, I do use the command line also. So in my opinion, what you should do is learn how to do the command line because it's very useful, and also find a tool that works best for you. uh, if you find that you know doing like using both is the best tool, then go for it. That's what I do when I need like a visual aid to see the difference between the files. I use the command line. I mean the GUI. When I need to do some weird stuff with Git, I use the command line. So in summary, learn how to use the command line very well. Learn every features of GUI, of Git, and once you're comfortable, then decide use the GUI or the other. It's not a big deal. Um, so I wanted to talk about that because I myself faced that question long ago, whether to just focus on the GUI or the command line, and I realized that it doesn't hurt if you learn both. So that's it. All right. So what do I want to do today? So basically, if you saw my last stream that happened like last Thursday, not this Thursday, but the last before one, the one before that one, what we did here. Hold on, let me bring this down because it's kind of all right. So we basically created our character, our astronaut character, and we created a terrain. We also added, we enabled the game controller to control the character. Let me turn it on so we can actually get to see what is it that we really did for that on that day. Um, Let me just. So here's what we did. We created the class, and I don't know. Can you guys see that? Let me actually make it a little bit bigger so that way it's easier for you guys to read. All right. Yeah, I think that's better. So in the Earth subclass, we basically initialize our character, which is the astronaut, and we created a terrain, which is a simple flat surface. And that's basically all what we did, and then, like I said, we also enabled the game controller to have an effect on that character. So let me run this so you know where we left off. All right. It's building, and we should see the astronaut, and again, floor. And now, when I move let me just put it here better. When I move the joystick, you see that the character actually starts moving around. All right. So obviously that's not all what we want to do, right? We want to make this cooler. So what I did, I actually went to see Trader, and I looked for some free models that I can use for that game. And I came across this model, which I thought was very cool. And I felt, you know what, why don't we buy it? It's only $4. And let's see where it leads us. So I bought it, and what I did, I imported all of those 3D models into Blender. I assigned the textures, I did everything, and actually you can see our character here, the astronaut, right there, right? So what we're going to do today, we are actually going to render or export those models and import them into the engine, and then render them. And then what we're going to do also, we are going to enable a first-person shooter feature in the game. That way we don't see the character, we actually see what the character is actually viewing at a particular location. All right. So let me bring this down. And one thing that I've been learning about doing Twitch is that if you're going to do game dev, you should prepare what you're going to be working on for that particular stream. So I decided to use Todoist and come up with a list of items that I'm going to be working on that day. Hopefully this helps, because in the past I've been forgetting what to do and my mind goes blank, and that's not a good idea. So the first thing that we're going to do, like I mentioned today, we are going to import the models, and then we're going to implement the first person camera. So let's do these 2 items first, and then we go into the other components that I want to work on. It doesn't seem like we have a lot to do today, but hey, let's do it. All right, so let me bring up Blender again. And I mentioned this earlier, but basically how it works is that the models that you that you decide in Blender, you can actually export them to the engine. And I wrote a Python script which basically does that for you. It will basically export all the attributes such as vertices, normals, textures, animations, etc. into the engine, so you don't have to worry about that. And how you do it, basically, when you're in Blender, you go to scripting, and then let me do it right now. You go to scripting, and then you open the file, and here basically you browse to where the script is located. It's a Python script, and you simply run it, and then you go back to default, and you're gonna get a tab right here. the left hand side of Blender, and you're gonna see an option to export. And when you click on export, you basically first you need to set the location where you want it. In this case, we want to export this in the resource folder of the engine, and you can export the type. In this case, we only want to export the data only, but you can export if you have animations. You can do animations, or you can do animations and data and animation and mesh data. It's up to you, but in this case we only want to export mesh data only, and we're going to call this a space asset .u4d. all right, so that is going to export everything over, and there we have it. All right, now this is all you need to do when it comes to export. However, since we are using textures, we also need to copy those textures over into the engine. So let me find those textures right here. I believe here, space game textures. So we need to copy all of these textures over into the engine. Let me bring the engine itself, and where are you? Untold engine resources. All right. So we are gonna just copy these guys and this one, and just paste them over here. And that's all what we're going to do right now. Yeah, we have that one. Sweet. All right. What's weird? Why is it showing up like that? All right. So once we have that, we need to come to our resource folder here and copy them over here too. You know, it's weird that it's not showing up the textures. Why is it not copying it? Oh, got it. Replace. Got it, there you go. All right, so we need to get this one right here, basically all of the ones that I copied over, and I need to copy all of this over onto here. And here, when you get these options, you basically need to tell the engine where are you expecting to run this game, right? In this case, we wanted to run it on the iOS device and on the Mac. So you could click finish, and we are set to go. All right. Now, I actually added, just to be prepared, right? I added the step that we need to do to add the models from Blender. So if you notice, many of these models that we have here, I actually gave them the same name, but with a different suffix. For example, here, the cliff right here, right? We have a bunch of cliffs that compose this game scene, and we do not want to give each of them a different name, right? It would be kind of dumb, because then we need to remember what name we gave it when we are loading the model into the engine. So what I did, I basically gave them all the same name but a different suffix, just as you can see here. Like I have cliff 0, cliff 1, cliff 2, 3, 4, 5. So when we load the models, what we're gonna do, we're gonna do something. Basically, we are going to parse the name, which is cliff, and then depending on the on the count of our array, we're going to say either cliff 0, cliff 1, 2, 3, 4, 5, 6. It's a nice way to do all of this this loading in a very nice way, in a simpler way. So basically what we're going to do first is we're going to create an array for our objects. In this case, we're okay. Let me show you what I did. So I'm going to do u4d engine, and u4d engine, that's the namespace of the engine. You can if you don't want to use it, you can just say using namespace u4d engine, but I like to use it. It's good practice. And then I'm going to create an u4d game object. That's basically the object of the representation of a 3D model in the engine. And in this case, now I'm going to call cliff, and I'm going to give it an array. And the value for the array, basically the size, is going to depend on how many cliff models we have here. So in this case, we have from 0 all the way to 12. So basically we needed to specify that we're going to have 13. All right. Now we're going to go into a for loop, and we're going to say int I equals 0, then I is less than 13, and I plus plus. And now here's where we're going to do our little parsing. All right. So we're going to do a standard string, then we're going to give it a name, and in this case the name is going to be cliff, right? Then we're going to get the name, and we are going to append our current integer I value. All right, so it's going to be std to string, and we append this value right here. Right. So now in the first pass, it's going to be cliff 0. The second pass is going to be cliff 1, on and on and on. All right. So once we have that, then step 3 says we need to create the instance. All right. So then we said, all right, so cliff I, then we say new u4d engine, u4d game object. Boom. All right. So we have that, and now we need to load it, right? And to load the attributes into the character, we use the function load model, and we need to provide the name of the model that we want to load and file where it exists. If you remember, that file is going to be a space asset.u4d, which is this guy right here. All right. So that's what we're going to do. We go to if, and then we're going to say cliff I load model. All right. And now for the name, we already know the name, right? So we're going to do name, and then that cstr. That basically will get the name of our current model during each pass in the for loop. And then we need to provide the name of the file, which is a space asset.u4d. All right. Once we have that, then we need to load the model, all of the attributes into the GPU. So what we're going to do, we're going to say cliff I, and then load rendering information. All right. And then finally we added the model to the scene graph. And if you don't know what I'm talking about, if you look at my previous streams, which all of them are located on my YouTube channel, I actually explain how everything works. All right, so cliff I, right? And now here, what I want to do also, what I want to do is I want to enable shadows for my terrain. So here my terrain should be, I think my terrain already enables shadows, but let me check. Yeah, it does. Alright, but for here I also want to enable shadows on the models. Cliff, set enable shadow and equals to true. Alright, so now if we render this, we should see some of the cliffs. And I think that should work. It will work, but the problem is that I forgot to properly set the camera so you could actually see the cliffs. But let's see if we actually can see it. Yeah, we can see that. Actually, let me change the camera position so that way we can actually see it. So let me bring this guy to like 5 and this one to 25. Hopefully we are able to see it from like far behind. There you go, we can see somewhat of the cliffs already. All right, why don't we keep adding more models here, 3D models, so that way we can actually keep seeing more stuff. Next thing, let me do one more so you actually can see it one more time how I do it. What I'm gonna do right now, I'm actually going to load these guys right here, which are called rock towers. Rock towers here. Which ones are the high rock? All right. Yeah, let me add those. All right. So we have 1, 2, 3, 4, 5 of those. All right. So let's do basically the same thing. We're going to create add. What were the rock towers? So basically it's going to be U for the engine, U for the game object, rock towers, and there's 5 of them, if I'm not mistaken. That's 5. All right. So following our steps, we then do a for loop, specify the model. All right. So now for int I equals to 0, I is less than 5, I plus plus. All right. So the first thing we need to do, we need to do the name, string name, and this is gonna be rock tower. And again, the name that I get from here, I'm basically just getting the name from my Blender itself, from Blender itself, but I'm not including the suffix. Just the name is the rock tower and not the integer. All right, so once we have that, what we need to do is we need to append the name and the current integer value. So it's gonna be std to a string I. All right, and after that we simply create that instance and then we load the model. So here's gonna be rock tower I new E for the engine E for the game object, and now we load the attributes. So we're gonna do that in an if loop. So here's gonna be rock tower I load model, and here we're just going to point to the current name. So name that ctr, I always forget that c to string, and then the name of the file, so space asset that e for the c string, right? Yep, that's the one. All right, and now once we are here, we want to, number one, we want to enable shadow on this model. Set enable shadow to true. And once we have that, we want to load this into the GPU. So load rendering information, and finally we just add the model to the scene graph. So add a child, rock tower, and boom, and we are done. Right, so if we run this again, we should start, we should see the rock towers also into the whole game scene. Uh-oh, I have a problem. There you go. I had a typo. All right, so there you go. You see you're able to see the towers here. All right, so now I know you don't. It's not. It's gonna be boring for you to see me load every single character. So what I did before actually doing the Twitch, I decided, you know what, let me prepare a bit so that way I don't make this boring. So basically, I loaded all of these models. I created that whole code already, so that way you just don't get bored and watch me see all this. Basically, I'm loading the high rocks, and I'm loading the trees and the cactus and the plants, and on in the rocks, trees. Why do I have trees here? I have two. Oh no, those are the old trees. Alright, and boom. So let's run this, and now we should see the whole thing. So on Tuesday, I'm going to be attending this webinar hosted by Git Tower. They're gonna be showing their GUI. I've had a chance to play with it before. It's really nice. But I signed up because I'm interested to see the new features that they have added into their Git Tower application. So I think it's gonna be like around 11 a.m. and let's see if it's cool. I will let you guys know. And boom, you see the models rendered. All right, So there's one little problem, right? What I want to do here is basically I want to create the whole feature that you see in first person shooters games, right? Where basically you get to see the whole environment from the player's point of view. Okay, so luckily I implemented uh, this type of features in the engine where you can literally set the camera to work as a first person shooter or as a third person or as a basic follow camera or a stable camera. I've done all of that. And the reason why I want to do it here is because I've been playing Battlefield, and believe it or not, what I do when I play games, even though I do like the gameplay, what I focus on the most is to basically see, like, if I see a feature in a game that I think is very cool, I start wondering how did the developers, the engineers, how did they make that happen? And I start thinking, you know what, it would be really cool to implement in the engine. And most of the times what I do in the engine or my plans for the engine comes because whenever I see a particular a graphical effect on a game that I've either seen other people play or that I had the opportunity to play with, I don't play games that much, but when I do, I'm very, very attracted to the features, like the graphical effects or like the physics that is implemented in the game, and that really gets to me. Like, I want to do that, and actually that's what really got me into developing a game engine, because I really wanted to know everything about computer graphics and about how a game works. I it really just that was the fuel behind my passion. I really wanted to know how that worked, and so since I've been playing Battlefield and I kind of like some of the features that they have, I figure, you know what, just to have fun, let's implement a game here that works as a first person camera with a first person camera. So we are going to do that right now. All right, so like I told you earlier, I actually went ahead and prepared the steps to do all of this. That way we don't have to I don't go blank, right, in my mind. All right, so first things first. So we need to create an instance of the camera, all right? And I do know I have the header already included. So let's create the instance of the camera here. So it's gonna be U4D engine, U4D camera. Let's call the pointer camera. And what I'm gonna do here, I'm going to basically create a singleton. All right. So it's gonna be U4D engine, U4D the camera, and then shared instance. That basically returns a singleton of the camera. All right. Yep. All right. So once we have that, the next thing that we need to do is create an instance of the camera interface and implement that with the concrete class of the U4D camera first person. All right. So what we need to do here is this camera. We need to include the U4D camera interface .h, and we need to include the U4D include U4D camera first person. Is it first person, or how am I actually working on this? First person, U4D camera first person. Let me copy this. We need to include this class here, so And before I forget, if you're wondering, well, I want to also do that in a game that you may be developing. How do you do that? Well, basically, I have all of that in. If you go to untoldengine.com, hurry up, and you click on learn and you go to docs. That will basically take you to that documentation page, which I've been working on. It's not everything that you expect, but I'm working on it. So, and if you scroll down to camera types, that will basically show you the different camera types that the Untold engine supports. So, for example, here we have the third-person camera, which is what you see here. Then we also have the first-person camera, which is what we're going to implement right now. That you get to see that, and we also have the basic follow camera, which you can implement. It's just a basic camera that follows the character wherever it is going. What we're going to do right now, we are actually going to implement the first-person camera. So, like I mentioned earlier, we instantiated the camera. Now we need to instantiate an interface in the camera type, and then we need to set the parameter for the camera. All right. And that's about it. So let's do that. All right, then create an instance. So it's going to be U for the engine, U for the camera interface. How do we want to call this? Okay, camera first person. Let's call it like that. Camera first person. And U for the engine. Oh, I'm sorry. We need to create new U for the engine, and then U for the camera first person. All right, so now that created that instance for our camera first person. Now what we need to do is we need to set the parameters for the camera type, such as the target. In this case, which model would the camera will be following. In this case, it's going to be our astronaut, but we need to specify that, and the offset that we want the camera to be with respect to the character. All right, so set the parameters, and let me bring up the function here. So it's camera set parameters. All right, so camera first person set parameters, and here's where we are actually going to provide the target. In this case, my target is going to be my astronaut. Let me get a pointer for that guy. Okay, astronaut. Oh, there you go. Astronaut. And then the offset is going to be, we're going to have it along the x-axis, going to be 0 units offset. And here, I did this earlier, so let me bring this up. Implement first person camera, and it's going to be 0.2 and 0.5. All right, so 0.2 and 0.5. And then finally what we need to do is, well, we need to set the behavior for the camera. And how we do that is simply we say, okay, the camera that we have here now that we have created, we set the camera behavior. In this case, the behavior of the camera is going to be the first person camera that we created. So camera set behavior, and we first camera first person. Boom. All right, let me see if I got the correct set camera behavior. I messed up with the all right, that should do it actually. Let me build this. It's building, it's building, it's building. Alright, hold on. I got something failed. Let's see what's the problem. Oh, of course, I forgot that H. Alright. Okay, so what's the other problem that I have here? Let me look this up. Come on, camera first person. Did I mess up something when I created this? Oh, well, that's because this guy is actually a singleton also, so we cannot do that. And shared instance. All right. Yes, I totally forgot that. I created that as a singleton also. All right, so let's see where we're heading now. Man, what's going on with me today? Getting a bunch of errors. Okay, now that should go. Now let me turn on my controller. Now what you're gonna see is that we are going to see the whole game scene from the perspective of the character, the astronaut. So let's see how that goes. All right. All right, so as you can see now, we actually are looking the whole scenery from our the perspective, the camera. Now, if I actually rotate the joystick, you know, you will see that how everything moves. Now, there's a problem. If you see here, the rotation of the camera is kind of very how can I say it, not primitive, but it doesn't follow the line of rotation properly. Depending on you know, I can just do that and it doesn't remember the previous location of where the character was looking at. It's not the interpolation between one direction and the other direction doesn't exist basically, right? Instead of the camera going from this point and interpolating, so let's say that I'm currently looking in this direction, and then I change the joystick to look into this direction. What's happening right now is that the camera is instantly going from this direction onto that one, right? So that's why you see like the whole changing in rotation all of the sudden. What we want to do is actually we want the camera or the rotation of the character to rotate depending on the interpolation between these two directions. So we want to interpolate all of the directions between these two angles, and so that the camera is slowly rotates the view, and it creates the nice illusion that we are, you know, the whole rotation is more natural and not too uh, rough. Okay, so let's do that right now. But before we do that, let's actually see where we're at. So we imported the models. That was good. Next we implement the first person camera. So that's basically we're set with that. The next thing that we need to do now is the game logic, right? In our joystick, what we're going to do, we are going to interpolate the directions, the whole rotations, so it becomes a lot more smoother to work with. Okay, so we don't need this. Let's go over here, and now we're gonna use to my game logic. And like I mentioned earlier, I prepared something here so we are not lost. Joystick. Alright. So let me bring this up. These are the directions that we are going to follow. Alright, so before I move on, honestly, we do not need none of these things because we are going to change some stuff. And basically what we had here is the current rotation of the character, which it doesn't seem very natural. So we're going to get rid of that. Okay, and we're going to get rid of this also. We don't need that. Okay, so here under the joystick, whenever there is a movement, we are going to interpolate between all of those, between the two directions. All right. So step number 1, get the entity forward vector. Okay, the forward vector is basically the default view that the designer created a character. In this case, our character is always looking, was designed looking out of the screen. We actually declare that here, the default view of the character. That's the entity vector, and we provided this vector which is basically looking out of the screen, and we set this vector as our set entity forward vector. That's the default view. Actually, now that I'm here, I think what I'm gonna do, I'm gonna change this method and call it default view, because I think that makes more sense. I'm gonna make a note of that. I want to change that. All right, so first of all, get the default view of the character, right? So let's create a vector for the vector 3n, and let's call this v, and our character in this case is p astronaut. And get entity forward vector. All right, we don't need to normalize it, but let's normalize it either way, in case, to make everything nicer. All right, so now we have the forward vector of our character. Okay, now you know what, let me, before I do this, let me actually explain to you what we're gonna do here. All right, basically we are going to first detect the current view direction of the character. Let's say it's this one. All right, and then we are going to get the direction of the joystick. Let's say the joystick is moving this way. Okay, what we're going to do is we are going to calculate the angle between the joystick direction and the view direction. Okay, And we're going to use that angle, and we are going to use the up vector to create a quaternion. Okay, and once we have that quaternion, which is basically the new orientation where we want, we are going to interpolate between the current orientation of the character, which can also be represented as a quaternion, and interpolate that with the new direction of the character that we want, which is what we are about to calculate. So once we have the quaternion for the character and the quaternion for the new orientation, we can do this interpolation between them, and everything will work out fine. All right, so that's why we are about to do this. Right now I'm want to get I need to get I got the default view. We're gonna need it very soon. Next, what I need to do, I need to set up an up vector and cross that with the view direction to get a sense of where the character is actually at. I not only need the up vector, I also need to know the x, either if it's moving to the right or to the left, and you're gonna see why we need that. It's a little bit hard to explain, but it's follow me. So let's declare the up vector. If for the vector 3n up vector, and this is gonna be a simple up vector. Boom. All right, now we're going to cross this vector with my entity forward vector. And let's call this pause direction, and basically v dot cross up vector. All right, now we will use this in a few minutes. All right, so now what we're going to do, we're going to get the angle between the joystick, which is actually here, joystick message direction, and my view, okay, which is basically the view that I got. So float angle equals v that angle, and then we simply provide the name for this guy, which is joystick message data that direction. All right, so that gives me my angle. Now here's where we check if the dot between the joystick direction and the view direction is less than 0, then flip the angle. Okay, actually it's not the view direction, it's the position direction here. Alright, so I just check if joystick message data that with the position vector, if it's less than 0, we flip the angle. And why do we need to do this? Well, we need to do this because when we start moving the joystick, we need to provide a way to tell, how can I explain this? If I move my joystick diagonally up this way, the angle between this vector and the new direction of the joystick may be 45 degrees. All right, but let's say if I move my joystick to the diagonally, but onto facing the other way, facing that way, Well, the angle between my default view, right, which is this vector, and my new angle is what? It's still 45. There's no way for the engine to know, hey, are you moving this way or that way? So we need to provide a sense of direction to the game so it knows what to do with the angle. Okay, such as if I'm moving this way, I'm going to that direction with my position direction that we got here, that we cross it, and if that product is, you know, less than 0, then we need to flip it, else we just keep on going. That's why we need that. Or else what's going to happen is that when you rotate either way, either to the right or to the left, the interpolation is just going to keep going in the same direction. It's not going to switch directions. It's just going to rotate like clockwise always, instead of saying, hey, you know what, there's a shorter path, let me just rotate the other way. I know it's a little bit confusing, but this is actually how you need to do it. This is not just related to the engine here, it's just how it works, that you need to be you need to keep that in mind. Alright, so now that we have the angle, we can create a quaternion. Alright, so it's going to be U for the engine, U for the quaternion, let's call it Q. Alright, and no, let's call it W, and we're going to provide this, we're going to provide the angle, and we're going to provide the axis. In this case, it's going to be the up vector. Okay, so now we have the quaternion that we have created it. Now we need to get the current orientation of the character, and we're going to get that actually using a method that returns a quaternion. Okay, so U for the engine, U for the quaternion, let's call it Q. So P astronaut, and the method is get absolute space orientation. Alright, and that basically will provide us with this quaternion. Basically it gives us the orientation in the quaternion form, which is what we want. Alright, so now we can compute the interpolation between them two. Alright, so we're gonna do U for the engine, U for the quaternion, let's call P, and it's gonna be Q, which is my current orientation, then slurp, we're gonna do a spherical linear interpolation, spherical interpolation. We are going to give the new orientation where we want, which is W. You know what, let's change this. Let's go new orientation. Alright, this is model orientation. That way is better. Alright, so now here we're going to do model orientation, and then it's going to be new orientation. Okay, boom. Once we have that, we simply rotate the character by that new quaternion, by the quaternion that was created here, which is P. So it's going to be P astronaut, boom, rotate by, and then we provide the new orientation, which is P, right? So with that, if we run this right now, you are going to see that the whole rotation is more smooth, which is basically what we want, right? So let's do that. And I forgot to give it a constant value for the slope. All right, so it's on. Man, I cannot believe it's already an hour had passed since I started streaming today. We are almost done actually. I actually thought that I was going to be done with this quite you know short amount of time, like 40 minutes. But I think it's gonna be an hour and a half or something. Alright, so everything looks good now. Alright, so now I'm going to rotate my joystick. And you see how everything now looks better? Boom, see? The whole rotation is more smooth because of the interpolation that we implemented right now. And basically all what we needed to know is we needed to know my current orientation, my new orientation, and then do a linear interpolation. And if you're wondering, well, why did we spend so much time doing the other things here and this and that? Well, what happens is this. I'm going to actually comment the section where we actually flip the angle, and I'm going to run this again, so you actually see that no matter if I move my joystick to the right or to the left, the whole interpolation rotates in the same direction. We still rotate, but it just goes in the same direction, which is not what we want. We want to either go from one way or the other. And I'm just commenting out that line so you can see, so that you could see why we do that. Alright, it's taking a while to load. Oh shoot. Okay, now watch. I'm going to move my joystick, and it's moving in that direction. Now I'm going to move my joystick on the other to the other direction, and you're going to see that the direction of the rotation is the same. It always goes the same way, no matter what, right? We are getting the right angle, the right value, but we need to inform somehow that we want to rotate the other way right now, and that's why we flip that angle, and that's why we need that. Okay, sweet. I just wanted to let you know why we're doing that. Okay, so now we added the slurp. Now what we need to do now is we need to add implementation for the right joystick. All right, what do I mean by that? What I mean is this. If you play a Call of Duty or Battlefield or any other game out there, you will notice that one joystick always deals with the orientation, right, where the player is looking, and the other joystick deals with the translation. Okay, one rotates and the other one translates the character. And that is what we are going to do right now. We are going to enable the right joystick, but the right joystick is going to focus only on the translation, the movement. That's what we're going to do. All right. All right. So let's see. Let me bring this over. Adding. Let's see. Okay, so what I'm gonna do is I want to copy this case right here for action joystick. And you may be wondering why are you gonna do that? Well, basically I'm just gonna copy it, and I'm going to remove most of the things that we did here. Okay, but now I'm going to change this to say action um, for my right joystick, and let me bring up the proper name. So it's going to be action right joystick, this one. So now this guy's only going to detect any actions that happen on the joystick itself, on the right joystick, alright? Also, let me remove this because we don't need this. And I believe we also had it here. There's no need to do this already. Alright, so action joystick. So here's where we're going to do our stuff. And like before, I actually have some of the comments that we need to do. Alright, so first thing first, we need to flip the direction of the joystick. You are going to see why we are going to do that. Now this is more depending on your game, but in this case I'm going to flip that direction. So whenever the whole reason why I have to flip that direction is because by default the character was designed to look out of the screen, right? So out of the screen, and if I move my joystick forward, well, he's going to keep moving that way, and we need to flip that so it actually comes the other way. All right. Okay, so we're gonna flip that direction, and then we're gonna get the orientation in matrix form of the character, right? Then we're going to transform the direction of the joystick by the orientation of the character. That way they are aligned. So we're going to do this. We're going to get the orientation of the character. Okay, so if the character is moving that way, okay, we get the orientation. Then if the joystick is moving up, right, in like removing the joystick in the up direction, what's going to happen is that the character, if we don't do anything with it, what's going to happen is that the character, even though it's looking in that direction, he's going to be walking sideways, and we don't want that. What we want is to transform this vector into the same orientation of the character so that it goes this way. Okay, so now when we push up, the transformation makes the character go into that same direction up over there. Okay, if the character was looking this way and you move up again, then we transform the vector so it keeps going that particular way. Now all of this is dependent on your game, but in this way this is how we're going to do it here. Okay, and after that, let's see, so we're going to flip that direction, so we're going to get that direction here, and we are just going to flip this by -1. Alright, so now next we're going to get the orientation of the character, and we're going to get U for the engine, U for the matrix, 3N, and it's going to be astronaut, and then the method is going to be get absolute matrix orientation. Okay, once we have that, we are basically going to transform the direction. U for the vector 3N V, and we're going to transform M, which is of my matrix orientation. I'm going to transform that by my joystick direction. Alright, okay, so we got that. Now once we have that, we are going to set the direction that we want to walk along. So P astronaut equals set force direction, which is going to be V. And we currently haven't implemented this particular method right now. We're about to implement it soon. And once we have that, we are going to change the state of the character, right? Because we know that like the right joystick should basically make the character move. So we're gonna do if be astronaut change get state, and if this is not equals to walking, let me check if that's the correct walking. Yes, to walking, we want to change it. Change state walking. And once we release that joystick, we actually want it to go to idle. If be astronaut get state idle, then be astronaut change state idle. All right, okay, so we got that. With that, we are all set and ready to go. Okay. Before, however, we just added this code right here for that right joystick, and we added that in the method which gets notified whenever there's an user input. All right. However, we haven't enabled the right joystick to receive any user input. So that's what we need to do next. We need to enable the right joystick communication. We are basically done with this, so we can just let this go. Enable right joystick communication. All right. So this is very simple to do. We go to my gamepad controller, and we look for the action on right joystick. If you scroll up, you see the action on the left joystick. Now, most of this is already set up for you, and what we need to do is basically copy and paste some stuff. First thing first, we need to uncomment this line, so that way this, whenever there's an action on the right joystick, we actually send a message to the game logic. All right. So we need to fill out what we're gonna say here, what we're gonna have here. And to be honest with you, all that you can do is just copy what we have here and paste it on the other one, because it's basically the same thing. There is a minor change that we need to do, and I'm gonna show you, but everything is basically set up for you. So if you look here, what we want is the data from the right joystick, right? And here we are actually referencing the left joystick, so we need to change that to right joystick, and here to right joystick. Joystick, and boom. That's all what we really need to do here. Okay, since there's an error here. Direction. Okay, we are done with that. We enabled that. So now in my astronaut behavior, we need to implement this function that I told you about, right? So let's copy this and let's go over here and let's implement that function. Void set function, and then we are going to get a vector here, vector 3n, and let's call this for force direction. All right. Let me create something here. Force direction. U for the engine, U for the vector 3n, and force direction. Okay, so in this method, we are basically just going to So force direction, and you force direction. All right. Now, because we have this now, we do not need this particular method anymore, set heading. Now, in my previous stream that I did, I implemented this method which gets the current heading of the character, and I implemented that because when we are applying a force is a vector, right? So it needs the direction and magnitude. Well, we needed to know which way to apply that force, and I did a mistake because we don't really need to get the heading the way I was implementing here. A better way is actually to get a force direction from my current orientation. So what I'm going to do here is I'm actually just going to get rid of this because we don't need it anymore and it's just useless. And is heading, we don't need heading. Actually, where's heading here? Oh, alright. So get the force direction. So here's gonna be force direction, and we are going to normalize it just to be safe. Let me see. And that should do it. So whenever so basically here on the right joystick, like I mentioned earlier, we are going to get the current orientation of the character. Let's say it's moving that way. We get the current direction of the joystick that way. We transform this vector to position along the direction of the character. And what we want is that we want to move the character on this particular direction. So that's why we are providing this vector as the force, was because we want to move the character that way. All right. So that should actually do it, and we should be done actually. Let Xcode process the files right now. Can't believe this took an hour and a half. That's weird. Well, not weird, but interesting. I thought it was gonna be a lot shorter stream actually, but good to know. Next time I'll keep that in mind. Set force direction. All right, I don't have it here. Oh, what's going on? Oh my gosh, dude, did I remove the one that I needed? Yes, I did. All right, so now build this. So they canceled the games for the next 2 weeks because I think it's a spring break, and some of the players they couldn't make it because they had family obligations. I don't know. I don't know why, but I'm not at that yet. So, but yes, they canceled the games, and there is another problem. What could it be? 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 Heading. Yes, where is that guy? Heading. There you go. There you go. Force direction. Boom. Let's build this. So yeah, so I think that during this time, many since the kids are out from school, I guess they go out on vacation during this time, and that's why they had to cancel the games because of the low. I guess people don't show up during this time as much. So yeah, that's why they canceled it. So I guess when I become a parent, I'll find out. All right. Okay. Now we are ready to play this. All right. So now when we run this, we should see that with my left joystick, I rotate the character, and with my right joystick, the character starts moving in a particular direction. All right. So let's see it. Let's do this. Oh, after this, I'm gonna go to the gym. Run a bit for half an hour or so, and then come back. And my plans for the weekend is actually to keep working on the engine. I'm gonna keep reading and brainstorming some ideas on how to implement a terrain system, so that way the characters that we have here, the astronaut, is able to go up hills. At first, I was thinking of computing that with collision detection system, but I realized that that's gonna be too much. It's gonna take too much processing power. So now, left joystick, we are rotating. Now, if I move up, we should move up. Look at that, freaking awesome! Now, if I move back, it should come back, right? Now, if I on the right joystick, if I move to the horizontally, it moves that way. That's cool. Now I can just keep on going. Sweet. Freaking awesome. Oh. Boom. Now, you know what? Let me actually, so you could actually see it better if you want to. You can actually, we can remove the whole first camera person behavior, so you can actually see the character. So let me run this again. And at this point, you're going to see the character rotating as it should, with the whole interpolations, but now you're gonna see it from a different angle, from a different perspective. And it's taking some time. Boom. All right. So now I'm going to make the character walk. Boom. Now I'm gonna rotate it. Boom. Rotate it. Walk. And you see, depending on the direction, so I can go back, forward. If I rotate the angle that way, the character that way, if I move the right joystick up, it follows that path, which is what we wanted. Alright, actually let me bring it up over here. We can keep going and going and going and going. And there you have it. Freaking cool. All right, that's all what I wanted to show you guys today. So let me clear that out. Boom. So for the next Twitch that I'm planning to have, we are going to add more animations, such as the animation when the character is about to shoot. I'm also going to add an animation manager. The animation manager that we have in the Untold engine basically makes it easier for you to just keep loading animations into the manager, and you don't have to worry about calling a particular animation with a corresponding method. You simply load it into the manager, and the manager will the manager basically implements one uniform set of methods that you can call on any other animation. And I did this because, for example, let's say that you have a walking animation, right? And you want to play the walking animation. Well, what you're going to do is create a method that says play walking animation. And in that method, you're going to say, walk animation play. But then if you have a shooting animation, you will have to create Another method that says play shooting animation and then play the animation. That's kind of not dumb, but it's not practical. So the animation manager, what it does is that you just load the animations into the manager, and whenever you're ready to play a particular animation, you just specify which animation you want to play, and the only method that you need to worry about is calling animation manager dot play, and that will play the current animation that you specified. So that's what we're going to do that. Next, we are going to create a state objects. And basically why we're going to do that. What we have right now, if we look into our code, and you go into our change state, right, which this change state method, we have 3 different states that we can go through, right? Idle, walking, we're going to have shooting. Well, this is okay when you have 3 or 4 animations, and they're not too complex. The whole states are not complex. But eventually, when you are developing a game, you don't want to use a state machine that uses a switch statement. That's not the proper way to do it. What you want to do is you want to create each state that you see here, and you want to implement them as objects, and they're called state objects. And what that does is that it allows you to keep adding more states into your game without you coming into the change state method and modifying this method every time you want to add a new state. Everything is decoupled. So all you do is just keep creating more states, and you let the state manager basically to deal with how to change the state from one state to the other. It's a very neat way to work with states. And then what we're going to do, we are going to create a message dispatcher. Eventually, what we want is we want to have the enemies move autonomously with a quick, simple AI system. And the AI works a lot better when you have a message dispatcher, so that way the enemies can talk among themselves. It makes everything a lot simpler. It may look complicated, but it's not. It's very simple how to implement all this. Alright guys, I think that's about it for today. Thank you so much for joining the stream. I'm thinking that I'm going to do my next one on next Thursday, but to be honest with you, I haven't come up with a final schedule when I want to do Twitch, and the reason is that I'm trying to figure out when is the best time for me to do this. I've noticed that if I do it in the evenings, I'm a little bit too tired, and the best time for me to do it is during the morning. But I do have a day job, so the only time that I can do it will be from between 5 a.m. to 7:30 a.m. Before I head to work. And I'm thinking of doing that because in the mornings I am a little bit more, I have more energy. But I haven't finalized my schedule yet. So what I recommend, if you want to be notified, follow me on Twitter or follow me on my Twitch channel, and that way I will send a tweet and whenever I'm gonna go live, or whenever I plan to go live next. Alright guys, one final note, I'm gonna post this on my YouTube channel, so that way you can have it if you want to review it. Thank you so much guys, we'll see you next time. Bye.